Welcome to Textbook Engineering Problem, where we explore complex engineering problems and discuss different methods for solving them. In this video, I'll be breaking down a problem and discussing different ways to tackle it. However, keep in mind that there is no one correct path for some of these solutions, and I encourage you to share your own insights and thoughts in the comments. Together, we can learn and improve our problem-solving skills. So, sit back, grab a notebook, and let's dive into today's problem. Today we're working out of Elementary Principles of Chemical Processes 3rd edition, and we're doing problem number 5.9. It says the volume of a dry box, a closed chamber with dry nitrogen flowing through it, is 2 meters cubed. The dry box is maintained at a slight positive gauge pressure of 10 centimeters of water and room temperature 25 degrees Celsius. If the contents of the box are to be replaced every 5 minutes, calculate the required mass flow rate of nitrogen in grams per minute by A. Direct solution of the ideal gas equation of state, and B. Conversion from standard conditions. Okay, so we've got our volume here, we've got our gauge pressure, temperature, the time it takes to turn over the box, and we need to find out what that mass flow rate is supposed to be. Part A, we just use the ideal gas equation. Okay, so let's convert all of these into usable units for this equation. And let's also convert this so that we're calculating what a mass flow rate is, because this is just pressure, volume, number of moles, gas constant, and temperature. Okay. So we need to know that if you multiply the molar mass of nitrogen by the number of moles, you'll get the mass of nitrogen gas, okay? So then if you substitute that in, then we get this, and then we can solve for the mass. This would be the total mass of nitrogen in the box, okay? Well, the mass flow rate, in their definition in the problem statement, they said the entire contents of the box are to be replaced every 5 minutes. Okay, so the entire contents every 5 minutes. Okay, so that is what the flow rate should be. Okay, so now we substitute that in, and we get this equation that the mass flow rate is equal to this. Okay, so now we have an equation for our mass flow rate. Now we need to turn all of these things into usable units, like I was saying before. Okay, so this is our molar mass of nitrogen. Our pressure should be the gauge pressure plus an atmosphere. Okay, so the gauge pressure is in 10 centimeters of water. Turn that into meters of water and then into pascals using the relations they have in the front of the book. Okay, plus 1 atmosphere. And that gives you this many pascals for the pressure. This was given to us in usable units. And this is the gas constant. And this is the temperature in absolute scale, Kelvin. And then we have our time in minutes. Okay. We plug all those numbers into our equation right here, and we get that the mass flow rate is this. Okay. In part A, we said that the gas constant was equal to this. And then in part B, they told us to calculate the gas constant instead of just memorizing what the gas constant is. We need to calculate what the gas constant is using the standard conditions that they gave to us. Okay, so the standard conditions are 1 atmosphere of pressure, this much volume, this many moles, at this temperature. Those are the standard conditions, and that's what the gas constant equals if you use this. Okay. And it has enough significant figures that you get the same answer. Well, that is it for problem number 5.9. Thank you for watching, and I hope you found this video helpful in your problem-solving journey. Remember, there are other routes you can take to arrive at the same correct answer, and I encourage you to leave a comment with any additional insights or questions you may have. Also, if you have any specific engineering problems you would like me to cover, please let me know in the comments. Your feedback is valuable, and I look forward to continuing the conversation with you. Don't forget to like and subscribe for more engineering problem-solving videos. Thanks again, and I'll see you in the next video.